Hey folks, welcome to day 3 of Advent of Code 2022. Still going strong, still having fun. Um, yeah, this problem was an interesting one today. It was a little bit more difficult than the last couple of days. So we're starting to see a little bit more difficulty creeping in. Not massively difficult, still pretty straightforward. Should be tackleable by most people, I would say. But yeah, definitely a little bit more tricky, a couple of more things to take into consideration. So with that said, let's jump into today's problem. I just, whenever I get to this bit where I have to describe what the elves are doing, I can't help but laughing. Today, the elves are going through their rucksacks. Apparently it was one elf's responsibility to pack all the rucksacks with their supplies for their journey, but he didn't quite follow the packing instructions, so you need to rearrange some of the items. You're told that each rucksack has 2 compartments in it, and that there's an equal amount of stuff in both compartments. Our input is this list here. So each line of this list is one item, and they comprise of just uppercase and lowercase letters. To find the items to rearrange, what we're told is that these are always an even number. Oh, I assume they're always an even number, I guess so. We're told that there's always the same amount in the first half as in the second half, and that the items that need to be rearranged are the ones that appear both in the first half and in the second half. What we're told to do is we're told to go through the entire list of all of them, find for each rucksack or each backpack which item appears in both halves, and then we're also told that that will have some value, and we're trying to get a sum of all those values for every single rucksack, and then that will be your answer to your puzzle. So in this case, oh yeah, and that's the other thing. Yeah, so the items, they say it's the prioritization of which items should be reordered, and in this case, their letters, the lowercase letters A to Z, have priorities 1 through 26, and the uppercase letters A to Z have priorities 27 through 52. So then, if you get in the examples, you see where's the first one up here. Both in the first half and the second half, there's the lowercase letter P. The lowercase letter P has a value of 16. And then for each of these, you figure out which is the common letters, add them all together, and you get your 157 for the sum. So that's what we're trying to compute for our input. So let's go to my solution to this. And you can already see straight away, I've done a big old lookup again. Which I have determined is actually unnecessary to solve this problem. But let's just see. We run our first section. It runs. Woohoo! Yeah, so for this, basically, what I've done is I have my line reading loop, as I've used in every solution so far this year. I read the line. I get out all the individual characters of that line. I use a little bit of array processing stuff here to basically split that one array of all the characters into 2 arrays that are equal sized. I think this works nicely in this instance. I assume that I haven't checked it, validated, but I assume each one in the list is the same size. I assume it's an even number so that it just splits nicely each time. So you could do sort of subsetting this more basically with just looking at the indexes. But in any case, you end up with 2 arrays that have the first set of values and the second set of values, which are the 2 compartments. And then I do an intersection operation here on those 2 arrays to find what are the common elements. For this, I assumed that the common elements could be an array. I didn't assume it would just be one value matched between the 2, which I think in practice it probably is. I made the assumption that, well, it's going to be returning me an array here, so I'll just iterate through the array and do a rolling sum of that, which I do here. So that's all this is, just goes through all the common elements and sums together the values. Now, the value part, I think I made this a little bit more arduous by hand than I needed to. I was trying to think what's the best way to look up all the integer values for the numbers. So what I did was I typed out the lowercase letters A to Z and assigned them their values 1 to 26. And I didn't want to type out all the uppercase values. I assumed I'd be able to do some processing on this to make it easier. So what I have done down here is I have a little regex matcher, which matches on the item, checks if it's an uppercase letter. If it is an uppercase letter, it downcases it, looks up the value from this list and adds 26 to it, because that's all that we're actually doing. There's just an offset of 26 to all the uppercase letters. So yeah, you don't actually need to do anything. You don't actually have to map out all of the letters. And then obviously if it's a lowercase letter, we just look the value straight up off the list. And then we're adding that to our sum here. So then our sum gets assigned into a hash of all the backpacks with an index that I've added, which is just going to increment 1 for each line that we've read. And then at the very end, we get all the values from the backpacks, sum them all together, and that's it. That's your answer. Something here, though, where I'm using a lookup again, and I did mention in the last video about using lookups for these kind of things, that they make sense in a lot of ways. Generally, if you have a finite set, it's fine, and this is a finite set. Obviously, it's just the letters A to Z, but that is still a bit arduous to type it all out. So oftentimes when you're doing something like this, if you're working on a really big system, you still don't want to have to type out loads of stuff. Like, what if this was 200 or 300 different inputs? You wouldn't want to type them all out. It's still a finite set, but you don't want to type them all out. So in a case like that, it can be nicer still to try and find a better approach. In this case, I thought of a better approach afterwards. So you could just look at what the ASCII values for each of these are, and then scale them to be what the range should be for this. So I can't remember what the ASCII value for A is, but the only thing that matters is that if they add 1 to each time. So all I needed to do was scale off whatever the ASCII value is. Maybe it's 90 something, 92 or something like that maybe. Scale that down to 1, and then add 1 each time to each one. And then this exact same approach, then detect if it's uppercase and add 26 then to that again. So that would also do it. Didn't think of that at the time. Well, I did. I looked up the ASCII table and went, those values those values aren't the same as what I want. So I just ignored them and just wrote this out instead. Didn't really take a lot of time, but again, if it was much bigger, you wouldn't really want to just type it out by hand. All right, so that is part 1 done. Let's have a look at part 2. Part 2, yeah. This one, we changed up a little bit. So it's not quite the same as part 1 is. There is still some common code that you're going to be using between these two. Specifically, the common code is going to be this part for me. My lookup and figuring out the value for a particular item. But the actual the way we're grouping our stuff together is a little bit different. So what we've been told now is that the elves are divided up into groups of 3. They each have a little like ID badge thing that is the same for it's the same for each group of 3 elves, and we have to try and figure out what that is. But we've also been told we actually don't know what the badges are, so we have to work that out. And the way we work that out is we're going to look at each set of 3 lines, and we're going to find the common character between each set of 3 lines, of which we're told there should only be 1, which I think is there is one, I think, only between them all, and I guess we have to assume that there's not going to be other ones that match between this line, and this line. Importantly, we're forgetting about the compartments now. So the compartments don't actually matter anymore, but now we're interested, instead of trying to compare across the one line, we're now comparing across multiple lines, and we're told it's 3. Nicely, I thought that they were maybe going to interleave the groupings so that we'd have to try and figure out for the entire set of everyone where they were, but they've actually told us, to keep it simple, that it's just each block of 3 in a row. So I read the first 3, that's one group, the second 3 are another group, and so on and so forth. And yeah, that's about it. So once we figure out which is the common item between these three lines, we need to calculate or figure out the value, the score value, the same way we did previously, and then we need to get the sum across them to get our answer. So let's have a look at the code. Got my lookup, same as I had previously, and things are a little bit different in here. Okay, so the first thing we're going to have a look at is I set up a new variable called the last content. So it was the contents of the last bag that was read. We initialize that with nil. And the first time this runs, all we do is we're just going to assign the values of the line we've read to that, and we're going to increment a counter. And then we go next, skip on to the next thing. So this last contents is no longer nil, so we move in to this other branch of the if else statement, and we figure out the intersection between the line that we've just read and the last contents. So essentially what we've done is we've got an array of all the items from the first guy's bag, and we have the array of all the items from the second guy's bag. We compare them to see what are the common items. There could be a handful of common items, you never know, or there could just be one. And then from that, we can check the next guy's bag, which is going to be the next part of the loop. So we'll exit out of this, we'll have a look at our counter and see, is our counter mod 3 equal to 0? So that is, the counter starts at 1, so it goes 1, 2, 3, and at 3 the modulo operation will be 0, so it's a clean division of 3 divisible by 3. In this case, because we're only on 2, that won't be true, so we skip past this entire if block. We'll increment the counter, and we'll land back in here for the third iteration. So now we're looking at the third guy's contents of the third guy's backpack. We'll have a look at his characters, compare that with the last content. So the last content I've overridden to be what was common between the first two guys' backpacks. So again, this could be a subset of things, or it could be just one single item. If it's one single item, we already know that we've actually found the badge number, whatever that item is. So you could actually early exit on the first comparison. If this was equal to 1, you could early exit and skip on, but it doesn't really make a difference. Not going to be a huge improvement anyway. So we've done that comparison now. So now effectively what's in last contents is absolutely definitely the one item that's common between all three backpacks. Now, because we've gotten there, we know that our count, modulo count, is going to be 0. So we enter into this. We do our value lookup, same as you did before. In this case, we've been told there's only going to be one common value between all three backpacks. So I'm not making an assumption around whether it's a list or not. So there's no sum involved. It's just a direct lookup. Get the value, assign it in here, and then I've renamed my hash from earlier. Instead of being backpacks, it's now groups, because it's a group of backpacks with a common. Assign my index the same way I did before. Add the value to it. I wipe out last contents because that will mean that I can enter into it again here. So we're now at another set of 3 to start from. And that's it. Increment the counter at the end of the loop. And yeah, once that whole thing exits, we take our group hash, get all the values out of it, sum them all together. And that's it. All done. Again, with this one, there is an improvement to be made here with the lookup. It's static. It's not like it costs a lot of time. It's just probably not the cleanest way to do it. Trying to think of some other things in here can be improved. Obviously, an early exit can be done here. You know that if you've compared the first two guys' backpacks and they only have one item in common, then you know that that has to be the item. Because when you do that, when you do the next comparison with the third guy's backpack, you know that, well, it's going to match the same. So it's just a computation. There's an excessive computation that you don't need to do. So you could short circuit it, pull all this logic into here, or you could check in here if the length of last content after the second comparison is equal to 1, then you could increment the counter so that it hits into this straight away. And it'll, skip. Oh, actually, no, you can't do that. You need to read the next line and skip it. Anyway. Yeah, so that's about it. You're still iterating through every single line in that solution, except you're just not doing operations on every third line if you found that the first two already have it. Anyway, doesn't matter. let's just ignore that. Okay, so that's day 3 down, day 3 in the books. I had a lot of fun doing this one. I was happy to flex my brain a little bit more than I have for the last 2. So that's cool. And this is how it happens. It ramps slowly and slowly and slowly until there becomes a puzzle, usually around like 10 or 12 or something, where you're like, oh no, that just got a lot harder. So let's be happy that this is only taking a short amount of time to solve these and do all this for now, because it's only going to get harder. But hey, that's fun. That's what we're here to enjoy. Anyway, thanks everybody for watching. I hope you had fun with this puzzle. And yeah, like, subscribe, do all the things, and I will see you guys tomorrow.